And now, since you have the dimensions of the arc and the density of the bricks used in the arc, which is 2000 kilograms per cubic meter, you now have all the information to calculate the mass of the arc. However, let's do it on a simpler shape together to give you some ideas. Imagine that you have an object, a cuboid, which is like a 3D rectangle, and it's empty inside through the entire object. In other words, it's hollow inside. The dimensions here are in meters, so this length here, it's 4 meters, this one here is 2 meters, then this one here, it's 1 meter, then this one here, it's 3 meters, and then finally, this length here is 1 meter. The density of the material that this object is made of is 1000 kilograms per cubic meter. You are asked to calculate the mass of this object. From the units of density, you can see that density is the object's mass, which is in kilograms, divided by the object's volume, which is in cubic meters. It means that if you know the volume and the density of that object, then by multiplying them together, you will get the mass of that object. So the density in kilograms per cubic meter times volume in cubic meters equals mass in kilograms. As you can see, the units can give you a very good hint for what needs to be done. You can see that the cubic meters cancel out, and you are only left with kilograms, which is a unit of mass. To calculate the volume of that hollow cuboid, we can imagine two separate cuboids. One has the dimensions of the outer edges, and the other one, the dimension of the inner edges. So this smaller cuboid is essentially this empty space inside our real cuboid. It's that hollow part. If you now calculate the volume of both of those cuboids, for the big one, you will get this times this times this, and you will have 8 cubic meters. And then for the small one, you will have this times this times this, and you will have 3 cubic meters. If you now take the volume of the small cuboid that represents this empty volume inside, and you subtract it from the big cuboid, then you will get the following answer. 8 cubic meters minus 3 cubic meters equals 5 cubic meters. And that is the volume of this hollow cuboid. And now that we have the volume and the density of our cuboid, we can calculate its mass. And so mass equals the volume of the cuboid, and we're talking about this hollow cuboid, multiplied by its density equals 5 cubic meters times 1000 kilograms per cubic meter. And you will get 5000 kilograms. You can see that the cubic meters here, they cancel out, and you're only left with kilograms. And there you go. You have the mass of your hollow cuboid. It's 5000 kilograms.